Hello everyone, my name is Vicitra anak perempuan Segarang and my metric number is 198839. So in this video, I'm going to show my solution for the second question given by our lecturer. So here the question consists of two parts, so part A and part B. So the question given for A is show that the Laplace transform of 1 over 2k cube time with sin kt minus kt cos kt is equal to 1 over square of s square plus k square. And then the part B is using Laplace transform solve initial value problem where the y double prime plus beta y double prime actually is plus beta square y equal to a sin omega t, where y0 equal to 1, y prime 0 equal to 0, where a, beta, omega are constant and beta and omega are positive, and consider omega equal to beta and omega not equal to beta and use formula given in part A. So we're going to start with part A. So the part A, we need to show this Laplace transform equal to this answer. So we take the left side. So the Laplace transform of 1 over 2k cube time with sin kt minus kt cos kt. So noted here that k is constant, so we can extract out 1 over 2k cube. So we extract out 1 over 2k cube, so left the Laplace transform of sin kt minus kt cos kt. Note here that the Laplace transform we can separate into two parts, so we separate it, so become 1 over 2k cube time with this part of Laplace transform. Laplace transform is can write as this L, and then this Laplace transform of sin kt. Then here the k is constant, so we can extract out the k, so the Laplace transform of t cos kt. Then we can so to solve this, we just look through the table of Laplace transform. So this is one of the example table of Laplace transform where we can get from the reference book or from internet sources. So we just find the Laplace transform of sin kt. K here is constant, so we look through the table. So here the number 7 the Laplace transform of sin at is equal to a over s square plus a square. And then for the second one is Laplace transform of t cos kt. Then from the table we get from number 10 where Laplace transform of t cos at is equal to sin square minus a square over by square of s square plus a square. So next we just proceed with substitute the transform. So we get 1 over 2k cube, and then the Laplace transform of sin kt from the table, so we get a is our constant is k, so we get k over sin square plus k, get k over s square plus k square. So k over s square plus k square, the first transform. And then the second one is k times the Laplace transform of t cos kt is from table we get s square minus k square over square of s square plus k square. So we get s square minus k square over s square plus k square power of 2. Okay, so we just solve this. So k, here we can factor out the k, so we get k over 2k cubed times with this two fraction, so we can solve this by we make this fraction as one term. So here got square of s square plus k square, here only got one term, so we times this fraction with s square plus k square. So k we already extract out, so only left s square plus k square, then here minus s square minus k square, and then over by s square plus k square square. So we simplify this, so k we can cancel out, we get 1 over k 2k power of 2, then here s minus by s, so get 0, and then here k, so I just rewrite it, so s square plus k square minus s square minus is plus k square over by s square plus k square square, then we can solve it by 1 over 2k square, then s square minus s square become 0, and then k square plus k square become 2k square over by square of s square plus k square. So this we can cancel out, so we will get 1 over s square plus k square square. So here we get the same answer with the question. So we finish with the part A, where we have shown that the Laplace transform of 1 over 2k cubed time with sin kt minus kt cos kt is actually equal to 1 over square of s square plus k square. So this is the first part. So next, so just now we have done with part A. So now we move to part B, where we need to solve the initial value problem given by this equation and this initial value. So the first step that we need to follow is we need to apply the Laplace transform to both of the equation. So we apply the Laplace transform to both of the equation. So the Laplace transform of this, the left side, and then this, the Laplace transform of the right side is sin omega t. So here we can separate the Laplace transform into two parts. So it will become the Laplace transform of y double prime t plus here noted that the beta is constant, so we can extract out the beta square, so become the Laplace transform of yt, and then a also constant, so we can extract out a, so become the Laplace transform of sin omega t. Okay, so here follow the step just now, so we just look at the Laplace transform table to find the answer. So from this Laplace transform, so we find the answer. So here I already rewrite the Laplace transform. So from the Laplace transform table, the Laplace transform of second derivative of function is equal to s square fs minus s f0 minus f prime 0. So here we will get s square ys, s square ys minus sy0 square ys minus sy0 and then minus y prime 0 minus y prime. Here is the Laplace transform of y double prime. And then move to the Laplace transform of function yt is from the numbers 24. So here our constant here is 1, so we get plus beta square ys and then equal to the Laplace transform of sine omega t, so we get omega over s square plus omega square, so we get time is omega over s square plus omega square. So we just simplify this, so we can substitute the initial value given where y0 equal to 1 and y prime 0 equal to 0. So here s square ys minus s over y0 equal to 1 minus y prime over y prime 0 is 0 plus beta square ys, then here to a omega over s square plus omega square. Then we simplify this, become s square ys minus s plus beta square ys equal to a omega by s square omega square s square plus omega square. Then we can move s into right side, so become s square ys plus beta square ys and then a omega over s square plus omega square plus s. Here we try to leave the equation in the function of ys. So here we can factor out the ys. So s square plus beta square ys equal to a omega s square plus omega square plus x, and then we move this into the right side and then left it in the function of s, function y of s. So here we get a omega over by s square plus beta square times this s square plus omega square and then plus s over by s square plus s square. So here we get our function y of s. So we move to the next step where we need to find the inverse of this Laplace transform to get the function of y in terms of t. The yt is going to be our answer. But then from the question we consist of 3 constants, and then the question asks us to consider where the omega equal to beta, and for the second case is omega not equal to beta. So we need to separate it into 2 cases, where the first case is omega equal to beta and the second case is omega not equal to beta. So we proceed to the with the case 1. So the case 1 here, case 1 where omega is equal to beta. So when omega equal to beta, so we can rewrite our ys. So our y, when omega equal to beta, so our ys become a our omega now is beta over by so when here, so we get s square plus beta square s square. When our omega is equal to beta, so become beta square plus s over s square plus beta square. So here it will become the square of s square plus beta square. A beta over by s square plus beta square plus s over s square plus beta square. So here we can straight away find the inverse of Laplace transform. So in this case, we just look through the so we need to find our yt. Our yt is actually the inverse of our ys, inverse of Laplace transform, where our ys is equal to a beta over s square plus beta square plus s over s square plus beta square. Okay, so here so we noted here that our a and beta is constant, so we can extract out the a and beta. And the most important thing is these two part we can separate, do the inverse Laplace separately. So the a and beta we can extract out with the inverse Laplace of 1 over s square plus beta square and then here plus the inverse Laplace transform of s over s square plus beta square. So see here, to find the inverse of Laplace transform, here we can use the formula from part A. So here the question is transform this into this, but here for part B is you find the inverse of Laplace transform is where we convert this into this. So actually from part A, so the inverse of Laplace transform of 1 over square of s square plus k square is equal to 1 over 2k cube sine kt minus kt cos kt. And then for the next term, we can find the inverse of Laplace transform from the table of Laplace transform. So here from the table, when we want to find the Laplace transform, we look this part into this part, but now we want to find the inverse of Laplace transform, so we look from this part to this part. So here we get from the table, so the inverse of s over s square plus a square, a is constant, equal to cos at. So we just substitute those into our answer. So a alpha, and then this time with the inverse of Laplace transform from part A, so we get 1 over 2k cube time with sine kt minus kt cos kt cos kt, and then the second part, our constant here is beta, so it will become cos beta t. So we just rewrite it in a proper form. So we get a beta over 2k cube k cube sorry, noted here that our constant is beta. Our constant is beta, so it's not become k, so it will become beta. So here is cos beta, and then here is also beta, and then here is sin beta. So here is actually beta, because in from part 1 our constant is k, but now in B, so our constant is beta, so k should be beta. So here also beta. Okay, so we further simplify it, and then here time is sin beta t minus beta t cos beta t plus cos beta t, and then this we can cancel the above beta with the below one, so we get a over 2 beta square with sin beta t minus beta t cos beta t plus with cos beta t. So here is our yt for the first case, where the first case is omega is equal to beta, so we get our yt is equal to a over 2 beta square sin beta t minus beta t cos beta t plus cos beta t. So now we move to the case 2, where our omega is not equal to beta. So if our omega not equal to beta, so our ys is still the same. So to solve this, we need to perform the partial fraction to this part. So let's do partial fraction. So here do the partial fraction, and that this is non-repeated but non-linear and non-repeated type. So it will become the above part is d is just constant ds plus e. You can use any constant, and then plus this is we use f s plus e. So we solve this, so ds plus e, and then here we need to time with s square plus omega square plus fs plus g time with s square plus beta square, and then we solve this. So the lower part we can cancel out, and then we become a omega, then we get ds cube s cube plus with d omega square s plus es square plus e omega square plus fs cube plus f beta square s plus gs square plus g beta square. So we try to solve this and find for the value of d, e and fg. So a omega equal to the s cube here and s cube here, so d plus f, and then factor out the s cube plus the s square here, and then s square here plus e plus g, factor out s square, and then the s here and s here, so plus d omega square plus f beta square, factor out the s, and then the constant e omega square plus g beta square so equal to this part. So we can form the equation. So we get d plus f equal to 0, and then e plus g also equal to 0. This is our first equation. The second, and then the third one is d omega square plus f beta square is also equal to 0. Gonna be third equation. And the fourth one is e omega square plus g beta square. This one is equal to a omega. So we get 4 equation here. So we solve these 4 simultaneously. So from 1 we get d equal to minus f, and then from 2 we get e equal to minus g, and then we substitute d equal to minus f into the equation 3. To equation 3, so we get minus f omega square plus f beta square equal to 0, and we factor out f, become beta square minus omega square equal to 0, and then we move this into this side, so we get our f is 0. Then the next step, we substitute e equal to minus g into the fourth equation. So we will get e is minus g omega square plus g beta square equal to a omega, and we factor out e, we get beta square minus omega square equal to a omega, and then our g become a omega over beta square minus omega square. This is our g. So our d is equal to minus f, so our d gonna be minus 0 is 0, and then our e is minus g, so our e gonna be minus a omega over beta square minus omega square, and then our f here is 0, and our g is a omega over beta square minus omega square. So here we get the value of d, e, f and g. So we just substitute d, e, f and g into this, so we get so actually our a over s square plus beta square s square plus omega square actually equal to, our d is 0, so our e minus a omega divided by beta square minus omega square, and then over by s square plus beta square. And then the second one is our f is 0, then our g a omega beta square minus omega square, and then over by s square plus omega square. So here we, after the partial fraction, so we will get this form, and then we proceed to the next step to find our ys. So after we perform partial fraction, so our ys now become equal to minus a omega over beta square minus omega square time with s square plus beta square plus a omega of over by beta square minus omega square time with s square plus omega square, and then plus s over s square plus omega square. So to solve this, the same thing is we need to look through the Laplace transform table. So we noted here that our a omega beta and this pi is actually constant, so actually we can factor out. So we want to find our yt is actually the inverse Laplace transform of this ys, where our ys is minus a omega over by beta square minus omega square times with s square plus beta square plus a omega over by beta square minus omega square s square plus omega square plus s over s square plus omega square. This is s, this thing. So same like just now, we can find inverse one separately. These three we can find their inverse separately, and then we can extract out the constant here. So it will become before we extract out, so we try to look through the Laplace transform table and then see which of the form that we can use, and then we try to modify our ys to become like that, so we can find the inverse easily. So here after I look through the Laplace transform table, so I get these two of inverse Laplace transform that we can use in we can use to find our answer. So here we get the inverse of Laplace transform of a constant over s square plus a square is sine 80, and then actually this is for this part. So we need to transform our ys into same like this form to get the answer easily. So we try to look through. So we need to have the above part constant and then the constant in the lower part. So this we extract out minus a omega over by beta square minus omega square times with the inverse of Laplace transform of s square plus beta square. Note that here the above part we need to have the constant beta, so we add beta here we add the beta, and then here we also add the beta. So actually it's same like this, because if we time this, so we can cancel out the beta, and then here we extract out the a only, because we need to leave the above constant where is omega. So beta minus beta square minus omega square, then times with inverse Laplace of omega over s square plus omega square, and then here the inverse Laplace of s over s square plus beta square. Next step, we just substitute this what we get from the Laplace table. So here equal to minus a omega over by beta times with beta square minus omega square, then the inverse of beta over sine s square plus beta square, we get sine beta t times with sine here is beta t, then here we get a over beta square minus omega square. Okay, here we get sine omega t. Okay, we get sine omega t here. Then this we get cos, our constant is beta, so cos beta t plus cos beta t. So we try to write the answer in a proper form. So we get equal to minus a omega sine beta t over by beta square minus omega square, and then plus a sine omega t over by beta square minus omega square plus with cos beta t. So now we find our final solution for case 2 where our omega is not equal to beta. So our answer is yt equal to minus a omega sine beta t over by beta times with beta square minus omega square plus a sine omega t over by beta square minus omega square, and then plus cos beta t. So here is my final answer. So if I got it wrong, so please inform me. Thank you.